So yeah, hello everybody. I guess if you can, if you are able to see here, I hope it's fine for you. And here, this is me, Daniel Suguwa. So hello everybody. We are going to see and witness the launch of the Vega C VV26 mission for carrying the Biomass mission here. And I will try bring it straight away here. Alright,
of the polar ice caps or
so this is what it looks like right now.
magnetic field of the Earth. These are typical
So
examples
yeah, I
of
hope
missions they are carrying.
the drop frame isn't that worse, you know. I'm a little bit nervous right now with the way
Yes, indeed,
how
the
the
news were
cellular
good.
network
We had
internet works,
another
but
check before
I guess this is still fine.
removal of the mobile gantry, which we see on the screen just behind.
Yeah, so this is how it looks like.
4
Maybe
hours before the liftoff to
meanwhile of
check that everything
waiting,
was fine before removing. And the last
I guess
weather
maybe we
check
can
just
try
mentioned was
check
1
out
minute
the
ago,
web
and
the
everything
launch
good,
kit.
so all is fine for lifting off.
Okay.
We have a slightly cloudy sky here, but the weather's actually been rather nice these last few days. We've had a bit of sunshine. I can see
Oh,
there
so that's how
on
it
the
looks
image
like.
the
Okay,
clouds
and
just
just
past
for your
us for a
information,
beautiful launch,
all of
of
the
course,
almost all of
sunrise.
the solid
The
rocket,
European Space Agency teams will be
almost all of the
operating Biomass on standby
Vega
for
here
mission control
comprises of
in the Space Operations
solid
Centre in
rocket
Darmstadt in Germany. Just over
solid
an hour
rocket
ago,
fuel
the
solid fuel
Operations
rocket,
Director
which
Jose Morales
mainly
took the report
composes,
call.
if I remember correctly, HTPB aluminium, but it's not that kind of raw aluminium. It's more like the aluminium oxide, if I remember correctly. Uh, and usually aluminium oxide, when it's actually inside it, it's mostly as the catalyst, you know, catalyst just to fasten up the reaction of the whatever is it. For example, if it wants to burn way brighter and what's on, that's what they're doing inside the HTPB. And also aluminium no, and also ammonium perchlorate is also one of the ingredient that's inside the solid fuel, you know. And looks like this is the flight operation director doing call out. Okay.
S-track go.
Scheduling go. Excellent. This completes the biomass roll call.
All right. So that's it.
Excellent.
This
So
is the
they
call.
are go for launch.
Back
We
them
are go for launch.
back
The
there
minutes
in
are
the
going away.
Darmstadt
6 minutes and
in German.
56 seconds
Looks
and
like
counting
in
to
Germany looks like they are
We'll check
ready
in
for the
with the
liftoff.
SOC teams after launch.
And for the
That's
upper
exactly when
stage, if you
Biomass
see a
will send its
slight
first
bulge
signal
after
home.
this
It's
very small
back here at the Vega
small
C
diameter. If I
centre.
remember,
We've got
that small
several
diameter
controls. Obviously,
in
this is
question
mission
is actually
control, but we've got another
Zephyro 9
control room, Samuel. It's launch control.
solid rocket.
Yeah, launch control center.
If I remember, it's not
if we compare
motor,
the
it's more like
rocket with
engine because
an
the
airplane,
nozzle can
then
swivel.
launch control
So in
center
this
is
case,
located
all
in
of
the
these
cockpit of this airplane, the rocket
all of these
propulsion
three
system.
stages
You can see
below
that,
the upper stage,
they are in charge
the
of preparing
below is actually
the last stage,
the bigger one. The
as
main bigger one
overseeing all these final
is actually
operations to get
P120.
the rocket ready for launch.
P120, if I remember,
Once the lift will be triggered,
P120C,
the
that actually
rocket is fully
shares
autonomous.
in
It goes
commonality with the solid
autopilot
rocket
after the
with
liftoff. In fact, you have
booster
two
of
teams.
this
The first
solid
teams
rocket
are actually running the operations.
solid rocket engine for
Follow
the
behind,
Ariane 6,
checking that
basically
actual
for cost saving
operations
measures
are
and
in
what's
line
on.
with the
And
expectations and checking any
and
if
below
deviation, then analyzing the
and let's just say
Laser focus
upper,
at this point
let's
is
say the second
getting
stage of it
signal to the
after the
launch Vega C standing tall
P120C,
on its pad.
upper that slight
Now, everyone
bigger
also
one,
has
but
their
still
eyes
smaller
on
than the
the
P120C
status panels. We saw
and
them earlier
bigger
on in the mission control
than
center.
the
The new
Zephyr 9
panels
is
there
actually
on the
Zephyr
left-hand side of the
14.
screen there.
And after
In
that,
green at
it
the
follows
right-hand
by
side.
the
it's a bit like the
third
track.
stage,
On
the
screen we can go
Zephyr
left
9.
if it's red, of course,
And,
we'd better
and
stop
let's just say it's
analyze
almost in common with the
panels.
with
Actually corresponds to
with the way how it
a
builds
tube
actually. So I don't have to explain too much.
system.
That's pretty similar in architecture and also how they built in. And the upper stage, if you see after the smaller Zephyr 9, the third stage, after that the fourth stage, just below of the payload payload fairing is the Avum Plus upper stage, which are powered by the RD 843. And in case you want to know, that's the Ukrainian rocket engine one. Do not be confused with the Russian. Russian has its own RD whatever. Ukrainian has their own one. Yeah, I know. It's because the name is also RD. If I remember, RD stands for rocket, whatever it is, rocket, whatever is it. But it's more like translated to rocket engine something. Okay. Okay, this is the range operation manager making call out for announcement for the T-4 minutes. Ready? Alright, T-4 minutes. Okay, the synchronized sequence has already started, so which means the Vega C onboard rocket has already started to getting ready for the sequence and for the preparation for flight. So which means it's already in sync with the ground control, and now it's already start up and ready for the liftoff. And while we're waiting for the liftoff, why not I show you guys this here launch kit. Let me try.
Parts of the Vega C launcher arrived actually by sea, as you can see, at the port of Kourou, and were then transported
All right.
to the space
So
center.
why not we?
The rocket is assembled step by step from several parts.
Is it looking pretty good? Okay. So why not we are talking a little bit about this. This is the launch kit for the Vega VV26. Here it is, and that's how you get how I get the mission patch for the flight VV26. But however, due to some complication with turning this into transparency, I just decided, well, we'll just go with it, just capture it as to what it is. And this is the mission. This one will go into the sun-synchronous orbit, basically a highly specialized low Earth orbit. Another way to say is the hyper-synchronized orbit, if I remember correctly, something like that, HSO. And total payload mass here will that Vega C will carry is 1,240 kilograms, or around 1.24 tons. Of course, metric tons, of course. And the launch time, and the mission is almost 1 hour duration long, which is 57 minutes. And of course, the satellite is Biomass for the European Space Agency, or ESA. And they will target this at an altitude of 666 kilometers with inclination of 98 degrees to the polar orbit, also kinda in polar orbit too, where they are going to scan the same patch of the area of the Earth every 9 months, and the Biomass mission is pretty straightforward. It's to check the forest to be healthy and what's on. Okay, T-1 minutes, and this is how the missions looks like. And this is how it looks like. You can read for yourself, but but you can see this is to check the forest health and what's on, and the mass at launch apparently is 1,131 kilograms. So that's it. This is how it looks like, and I'm not going to waste your time. And this is the flight mission. Okay, that's it. Let's go back to the mission point. Okay, and now this is around T-minus 26 seconds. We are ready for liftoff. And to viewers watching this, thank you so much. Okay, and we are going to go with the ILS style right now. And this is Vega mission control at T-10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, and we have liftoff and already cleared the launch pad tower from the Vega launch site, the ELV. We have liftoff. We have confirmed liftoff from the Kourou, from the Guyana Space Center. We have liftoff, and it looks like it's rocketing ahead and already going from the cloud overpass. And now we have already seen it back around. And by now, almost going into Mach 1, which is the all right to be breaking the sound barrier. All right.
Over the Amazon rainforest.
Yeah, so this is how it looks like. So apparently it's morning day right now. It's there.
On its quest to
Nice.
forests just like the one it's lifted off from, on its mission for Earth,
All right.
for our future. We can hear it flying over the.
Amazing.
Yeah.
You can feel the,
So, like they
walls.
said, amazing picture. We have seen the liftoff.
He's telling us that everything is going well.
Yeah.
Yeah, so far it's perfect. We're lucky.
And looks like it's still rumbling.
Given the speed we had at the beginning.
Might be almost max Q by now.
Some great views here from our
Maybe
cameras.
already Mach 2 plus right now. But already almost 2 times the speed of sound, or maybe already 2 times the speed of sound.
First stage here, which is getting us away from the gravity.
Okay. And by now, almost ready for the solid rocket engine burnout. We are going to see and ready for it.
The orientation of the thrust as well. So it's
Okay. By now, or by my calculation, it should have already burned out right now.
Coming up
Okay.
on the
Solid rocket
separation
rocket engine on the first stage has already tapered off and ready for the interstage separation.
Everything's going according to plan. Fantastic.
Okay.
news.
actually we could see it from the
Should be.
cameras.
Zephyr 40 by now should be ready to ignite.
Seconds now.
Indeed, this is the scheduled moment for the.
Alright, and looks like we have separation of the first stage and we have ignition of the Zephyr 40.
So he's just confirmed that
Looks like we have a liftoff. Looks like we have ignition of the Zephyr 40. Some slight confusion, but it's totally fine.
Everything's going normally.
Okay, and flight looks like nominal, if I remember correctly, the term, not to be confused with nominal, if I remember. Okay, and now at T plus 3 minutes and 6 seconds, the flight looks like pretty good.
Fantastic. We're seeing it. We're 3 minutes and 11
Alright,
seconds into the launch.
and looks like we still have
See it with
good
our
visual.
cameras, which
Looks pretty
is
good
very
and
exciting.
nice,
So we've got the
especially on the
here at the
sunrise view
Space
of
Center.
the
Amazing.
Amazon's rainforest.
Several
Looks like
weeks
pretty
of
good.
rain and suddenly it's been very clear and beautiful. He's telling us
Alright.
the trajectory of the rocket is
Alright.
normal.
Trajectory of the rocket looks like nominal.
And of course the fairing, which is where
Okay, and ready for the fairing,
encapsulated at this
payload
point.
fairing jettison.
Samuel
We'll
is,
see.
the
It's going to
nose
split
if you like.
split into half, and then for the first time ever, the payload will be exposed to the space environment, to the vacuum space environment. That's it. We are going to see that.
Guyana environment, the rain and the dust, everything. But also at liftoff, we have when we.
Alright, so this is the animation right now.
High acoustic vibration.
Alright.
And the fairing is used to damp it.
Alright, looks like it doesn't block the view,
We go through the atmosphere,
so I don't have to
it
adjust too
helps,
much here.
reducing,
Yeah, so
the heat loads,
so slightly
the friction with the
slightly
atmosphere,
lower
or the vibration.
orbit than usual, but nothing to worry right now.
Piece of,
And ready for the Zephyr 40 separation, and ready for the Zephyr 9 ignition. Okay, and Zephyr 9 has already ignited.
So we just confirmation that the Zephyr 40
Okay, and payload fairing has already jettisoned. And now, finally, biomass satellite has now been exposed to the space environment, and you can see the southern turn of the rocket is pretty normal. Maybe you want to know why? Because it's that we are heading into the orbit, not the space, and that's the reason why.
Yeah, on
Southern
the
turn
left
is
of the
that
screen,
to
you can see
so
our
it will
first
be able to go to the orbit
passenger with, of
as
course,
efficient as possible.
its radar and solar
So
panel full
that's
out.
that.
It's attached to what remains of the launcher, which is rather small as compared to what was on the pad.
All right.
Through the adapter, this black cone, and then you have the upper stage, which is
All right.
a tiny, a slice, a white slice of the launcher, and on the left,
Nice.
the
But however,
destination stage,
even even if
which
the
is
even if the graph,
our passenger.
the expectation versus the actual graph looks like slightly have some kind of runaway from visual. This is something not to worry about, because this is what the upper stage, the altitude and uh, Verniers upper stage actually is for. That's why Album Plus is here. You know, where it's going to ignite the RD843 engine that will. It is actually a liquid filled upper stage, which is actually a hypergolic stage that's actually consumes dinitrogen tetroxide as the oxidizer, and the unsymmetrical dimethyl hydrazine as the fuel. Yeah, it's pretty nasty, pretty toxic, but if it works, it works. But that's why everything, no matter whatever you feel in, there must be some precautions needed. I mean, you need to handle this the fuel, the solid rocket, whatever, treat it equally as if it is a chemical hazard, so, and also danger,
8 kilometers per second just for
So that's that. That's why. Okay, and looks like we have already separation of the Zephyronites. Okay, and this speed or the velocity almost enough to go to orbit, but this is the final one of the step where it's going to ignite the Avum plus upper stage. We are going to see that RD843 will ignite soon for the first burn, and for the second burn, it will be used to circularize the satellite into the sun-synchronous orbit around 666 kilometers. Fun devilish altitude at the inclination of 98 degrees, going to the north. Basically, also a kind of polar orbit too at the same time. And Chef already reached. Chef already telemetry acquisition at the Bermuda and ready for the Avum plus upper stage. Okay, Avum plus upper stage has already ignited. Alright, Nation has already confirmed by the branch operation manager here.
And that's an important moment, an important milestone. We've really started the next phase of the journey, because the Avum Plus is a little bit like our orbital driver. Its job is to deliver our passenger to its drop-off point in space, and that's a very important job.
Yes, indeed, and it's the Avon Plus job, as you said.
Yeah, and right now the altitude is 282 kilometers. Distance from the Kourou is 2200 kilometers, with the with the velocity of 7.56 kilometers per second. That's faster. I mean, seriously, that's faster. We are talking about almost 20 times the speed of bullet, or the velocity of bullets, whatever you like to use. Even though per how do I say per, if we want to be formal, speed and velocity is not actually the same. Not actually not actually the real term that can be used interchangeably, but for the sake of um, understanding and ease, and basically for the sake of understanding it between the scientific community and the normal user, maybe such as you guys, how I have to use the velocity and speed pretty much interchangeably by now.
It means they manage a
All
group
right.
of companies and suppliers. Each of them play a super important role, and we have many industrial teams from Europe, but as well from US or Canada, which were involved in delivering hardware
All
for
right.
biomass.
So it looks like it.
In particular, as you mentioned, the satellite platform was assembled in the UK, indeed.
Okay, so right now it's already going a bit upper right now because it tries to target to the higher altitude orbit, so that's why they have to point that attack angle a bit upward there, as you can see.
So let's just check where we are in the flight. We are climbing
close to 300 kilometer altitude.
Yeah.
And 3,000 kilometers.
And then need to give a little bit more information is that after the first stage of this ignition, it will do some ballistic course phase. Basically, it's not going to ignite anything. It's just stay there. Okay, already pick up signal at the Gatineau in Canada, and then after the first burn, it will basically just relax and costing a little bit along the Earth for some few tens of minutes before ignition of before the second ignition of the avant blast upper stage, and after that it will just shut down, and then it will finally for some few minutes after that it will release the biomass satellite to the intended orbit. We are looking at this right now.
In French, or the quick look telemetry team, and we can see them actually in the bottom right of the screen there. Our colleagues, your colleagues there, Samuel. They're on a hilltop, aren't they?
All right.
The spaceport.
Yeah, very close to the spaceport on La Montagne des Pères. And they are actually, as you said, receiving the major flight parameters from the launcher.
All right.
All along the
I mean, even though we have some slight problem with the drop frames, I hope you guys can still see this. And thank you so much for viewers that's still watching this. Or maybe if you're new viewers, returning viewers, you're still appreciated here. Very, very much thank you. And once again, I need to repeat that around 30 minutes ago, we have the liftoff of the Vega C flight VV26 that actually carries the ESA's, the European Space Agency's biomass satellite payload for the Earth observation mission, especially to check on the forestry health and what's on, anything related to the Earth, you know. And looks like we've already reached altitude around 309 kilometers. Distance from Korea is 4,200 kilometers. Funny number also. And the speed or velocity is 7.77 kilometers per second. And looks like we are ready for the first burn shutdown, and then it will do ballistic course, not doing anything for tens of minutes. So it will be able to circularize the, so it will be able to optimize some of the fuel needed to finally circularize the orbit, of course, the Earth's orbit. And for your information too, Biomass satellite here, it's going to the same spot of the same place spot of the Earth once every 9 months. So they are able to check that what's happening with the forest. Hopefully, it's good. And for your information, this Avant Plus is upper stage is actually a hypergolic liquid fuel fill upper stage, which means it doesn't require any external igniter at what's on. Only fuel and oxidizer just combine together and it would just ignite straight away inside the rocket engine's combustion chamber. And yeah, the oxidizer is the dinitrogen tetroxide. The fuel is unsymmetrical dimethyl hydrazine. So pretty nasty fuel, and also nasty oxidizer. Not something you want to breathe in because it's also going to destroy your lung. So that's why every time they have to fuel this, they have to use the hazmat suit. The hazmat suit, you know. Basically, I have to feel it like a pretty nasty chemical stuff, you know. Okay, and first looks like the first wind has already ended.
For the confirmation
Alright, already confirmed. And now it's doing the ballistic pulse threads right now for tens of minutes.
So it's just saying that
before you be ignited once more again for the second burn. And this is to optimize not only the orbit but also the fuel usage, and especially if you know about the Oberth slow, you know why this is very important phases. You know, this is very necessary.
So we just stop it, and it's all very normal.
And while around these phases, the rocket itself, along with the payload, will actually orient itself. Not only just orient itself, sometimes it will do a little bit what we call this as the barbecue, sort of like the barbecue roll. Yeah, because the need of to continue protecting the payload and also the rocket from overexposure of the over the sun, over the solar, let's just say like it's solar sunlight, you know, constant exposure of this sunlight, especially in space. You know, if you know everything about something unprotected sunlight, how do I say, the sunlight particle stuff, it's pretty nasty and it's going to damage the electronics inside the rocket and inside the payload. So that's why they have to keep it. So that's why they have to keep it safe. They have to do this some occasional barbecue roll maneuver sometimes, or sometimes it's just going to flip up down, you know, 180 degrees turn, you know. And they are going to do this up until the second burn. So that's that. And this is a little bit boring. This is a little bit boring phases too at the same time. So feel free for you guys to actually just go. Feel free for you to go and do whatever you want for now. You want to go to for a drink. You want to go for food. Maybe you want to play some games. Here's your chance. Yeah, and you don't have to see me right now. You can just go and safely just listen to what is it, you know, just listening to what we are saying for the Arianespace feed and also mine. Feel free to do so. And if you're watching this on the replay, you can also safely keep this part. This is boring. There's not much else you want to see. Feel free to skip up until the second burn.
We were also hindered by the fact that we were in the middle of the COVID crisis when the most people should have been in the laboratories. And finally, to mention as a challenge is that the instrument cannot be tested on ground, and we have to rely on tests and analysis, and we will only see the final outcome once we are in orbit.
Oh, so basically, most of the instruments or all of the instruments can only be tested on orbit or in orbit. So this is very important test and analysis. So let's see what's the outcome. Hopefully this is good. Okay, and for now, there's not much else to do. So I'll leave you guys hearing the Arianespace fit for now. You will see just going to see me my avatar just moving in and whatnot, but I'm not going to comment anything for now.
home, then it will
Not
unfold
not
a
much else you need to know.
wing.
So that's it.
Start all the process
See
of
ya
being
guys.
tested before actually it can begin its job of scanning our forests, which should start in 6 months from now.
Indeed. And the teams at ESOC operate all the European Space Agency's
Ah,
satellites. That's
so
more
a
than
little
20
bit
of them over the years.
a little
And
bit
they also
relaxing.
take care of ESA's network of tracking stations. They provide world-class expertise for flight dynamics and mission operations. And it's also home to ESA's space safety program. So it's a busy old place. Thomas,
So that's it.
Austin is
You guys
a
won't see me
spacecraft operations
talking
engineer,
for
part of the team
some time.
flying the satellites.
So hold tight.
He's one of the people in
Hold
charge
tight. I
of
will
our
be back again.
biomass today.
You
Let's go
still
to
remain to
Thomas
see
now.
my avatar here. Okay. And to the viewers that coming here, welcome. Around almost 22 minutes ago, we have the liftoff of the Vega C rocket, which right now carrying the Biomass satellite. Currently, right now, it has already done its first burn, and right now it's just do this ballistic course phase, basically doing nothing, but just to course along, just surfing around the Earth's orbit up until the second burn. I mean, try to imagine this in ocean, but if you're just keep floating and floating and floating until you decided, hey, I'm going to open up this let's just say rocket equivalents on Earth. I'm going to open this get off the burner. I'm going to open it up, boom, right, and then you're just going faster and faster until you reach that equilibrium, or basically the equal point of the altitude. In this case, the Biomass satellite, they are targeting at 666 kilometers altitude. Yeah, funny devilish number. Where they are targeting the inclination of 98 degrees, going to the north, basically a kind of polar but also low Earth, but at the same time sun-synchronous orbit. So that's what they're heading for. Okay, and for you watching here, don't be surprised if I'm not talking for a little bit. Some things to do, but it's totally fine. I'll be back again to talk. So here you go, the Arianespace fit for you for now. So see ya. And if you're watching this on replay, feel free to skip this part. This is boring.
So this is actually a very good thing. This is actually one of the few things where forests are known for. Is that actually there's a very natural way of capturing carbon, and actually the forests are growing from it. So it's actually a very, very nice thing. The remaining part is going into the ocean, and for the oceans actually it's kind of a bad thing. You get an acidification of the oceans, which is really detrimental for the ecosystems and biodiversity. On top of this, the Biomass mission will especially look at the tropical forests, and this is exactly the areas where the largest unknown. So we have a gap in our knowledge, and on top of this, there's also the place where we know the largest changes are occurring.
Yeah, exactly. And I mean, when we're looking at those things, I mean, we've had radar missions from ESA before. These are studied in other ways. I mean, what is it about Biomass's radar that makes the technology so unique and so special for this?
Yes, I can tell you about this, Thomas. So as you mentioned, ESA has been flying radar missions before, and the type of mission that they're flying, type of technology, synthetic aperture radar.
Sometimes kind of fun playing around with my avatar. So if you're seeing me a little bit playful with my avatar, it's totally fine. And yeah, as you can see, the upper stage and also the payload, they are doing a little bit, how do I say, let's just say sort of like the combination of the barbecue roll and also some let's just say somersault like maneuver there. because they want to cool themselves from the overexposure of the sunlight, and overexposure of sunlight is not very good in space because it's radiating that free free radical particle, whatever is it you want to call it. So it's not pretty good. So that's why they have to roll it once in a while, And also the second reason is that if you see right now is because they want to charge the satellite so that by the time the satellite also separated, it has some kind of batteries, enough juice to start commence not only the testing, the operational testing, but also to fully operate it at some points. Usually it will operate around, it depended on how long it will be tested, but sometimes it can take, in the span of, let's just say, if you have small satellites, it could take a little bit of just a few days or maybe just one day only to few months for some important satellites like this one from the European Space Agency's Biomass satellite here, the ESA's satellite here. Very important because this satellite actually will not only going to check for the forest cover also, but at the same time they are going to check the effect, what happened. Let's say, for example, if the forest, if that patch of forest no longer there around 9 months after the observation, yeah, because they are checking, they are orbiting and also going to check the same patch of the forest every 9 months. So if they check the forest isn't there, they have to calculate the effect of how many carbon dioxide, how many carbon related whatever molecule materials there will be released on at the atmosphere if the forest no longer there, and also to do the analysis regarding, let's say, for example, to check because this is something concerning about climate change. I mean, if you guys even learn something about this, climate change is pretty much real issues that we have to deal with in the first place. Yeah, as time goes by, it's getting our Earth is getting hotter and hotter and hotter and hotter. So this is considering as a way to do some check and balance, for our Earth's healthiness, So that's why. And I guess that's all. I don't have too much to say here. And for you guys that's still watching here or maybe still coming here, welcome. Around almost 28 minutes ago, we have liftoff for the Vega C rocket for the VV26 mission carrying the European Space Agency's Biomass satellite. And we've already done the first burn and currently just chilling around the Earth's orbit, just orbiting around doing nothing for tens of minutes before the second burn of the Avum upper stage, which will finally circularize that satellite to 666 kilometers of altitude with the funny devilish number at inclination of 98 degrees up to the north, of course. So that's that. And I'll be back again sooner or later. I want to keep myself rest for now. So that's that. So you're going to see me with this avatar, but rest assured I'll be back again soon. So that's that. So that's it. Let me do a little bit standby for now. You still can see this.
Not long from now, from the upper stage of that Vega C launcher. But for now, I would like to say thank you very much to our launcher for giving us a gentle ride. We will continue enjoying it here in the control room, and we will be back to talk to you later once we've separated to catch that all-important moment of first acquisition of signal. Thank you very much. Back to Katie.
Thank you so much, Thomas and Bjorn. So great to hear from you both and have such a fantastic description of this terribly, terribly important satellite. Okay, so we're going to take a break now because we're coasting without the engine. So we're going to cut our mics for 20 minutes. We're coming back at 7:05 Kourou time. That's 11 here in UCT, Universal
Wow,
Time,
20
5
minutes.
past
So
12.
they also want to have some
If
break,
anyone
just
wants to
like
ask
me.
a question,
Okay.
Put them in the chat.
yeah,
So,
put them in the chat box on YouTube or any of the social media. I think you'll do your best to answer later. Okay, see you in 20 minutes. Bye.
Goodbye.
all right. Okay. So they also already take a rest right now, and I'll do the same thing. 20 minutes of doing nothing, but you're going to see my avatar here just moving and whatnot. That's totally normal. I like to play with avatar once in a while, so keep an eye of that, and keep an eye of the upper stage and also the biomass satellite here. As you can see, this is the real-time animation view, and looks like the commentary will start again around T plus 15 minutes. Okay, so yeah, it's almost 20 minutes of silence from me. Maybe, maybe I'll occasionally just going to talk again, sort of like if try imagine this is like in magical girl in anime or 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 basically cartoon, just basically knocking you around with no 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 knock, hello there, are you there, like that. So yeah, occasional knocking from me, so that's totally fine. Hopefully you're alright with that. So that's it. See you again sooner. Bye bye, and I'll occasionally knock the door quite uh, maybe every few minutes, I guess. That's it. Yeah, I forgot I should open the music, but here we go. Just enjoy the chill music, and the most important thing is the music that I'm using here is not AI generated. It's certainly not AI generated. You can check the source if you want in the description. It's 100% human made. So yeah, uh, in case you might wondering, this is not an AI generated music. This is real music made by humans. So that's it. So chill out. Yeah, so hello guys. Now this is a little bit like knocking the door, I know. Once in a while, I need to tell you something. We are looks like this. If there is also if there's no problem so far, and let's just say if there is no problem with the Firefly Alpha rocket for tonight, we might see the launch of it around from what I can see around 3 hours plus from now, and then going to be followed by tomorrow. We are also going to see the Shenzhen 19 touchdown and landing in Inner Mongolia, really very near to the Jiuquan satellite launch center there. You know, basically where they also launch their astronaut there. So that's why. And yeah, forgot to also told you that Firefly Alpha rocket will carry the LM400 tech demo satellite from the Lockheed Martin. So we'll see. Hopefully, no more scrub. Hopefully, they've already solved the problem. So looking forward to it. To that, you know. Plus, I don't want my schedule getting way back than what I can handle. So hopefully they are able to solve this as soon as possible. You know. So that's that. That's a little bit obligatory. Not really obligatory, more like complimentary door knocking right now. So yeah, I'll see you guys again in a few minutes if something's popping up in my mind. Okay, so some door knocking again. Just in case you want to know, almost already 40 minutes and 20 seconds ago, we have seen the liftoff of the Vega C for the VV26 mission that carries the European Space Agency's ESA's Biomass satellite that mostly for the observation of the Earth's forestry, and also to do some side climate change observation too at the same times. Climate change observation too at the same times, because they also mentioned before that they're also going to check something related to ocean acidity, something like that, if I remember. So that's that. And right now it's still doing this barbecue roll and also slide somersault turnaround. Is that to keep the payload and keep the satellite and also the upper stage cool down, so that it's not overexposed to the sunlight, because sunlight in space is not that ordinary kind of sunlight. It's like, how do I say, it's pretty nasty in the space. There is no protection, there is no filter out there that's going to block all of that ultraviolet, the free radical particles from literally bombarding the satellite and also the upper stage. So it needs to do that to cool itself down. And also some of this sunlight also already absorbed by the satellite's solar panel, so that the batteries will be able to charge, and they're also able to go this the operational check and also test right away after the separation and after the signal acquisition by the ground control. So that's that. And also forgot to mention to you that I think, yeah, since we are almost in the commentary side, might as well I tell you something that tonight, if there's nothing that keeps stopping the Firefly Alpha from flying, from finally liftoff, we are going to see it around almost 3 hours and 40 minutes from now. And also and also tomorrow we are going to see the Shenzhou. Let's say if there's no problem too, because they shifted that. For some reasons, they shift it to almost a day, which is tomorrow, where the Shenzhou 19 crew, the Taikonauts crew, they will be landing in Inner Mongolia, yeah, basically around the area near to the Jiuquan Satellite Launch Center, which is very near to where the astronauts also were launched for most of the Shenzhou main mission, So that's that. And also another one is that around the 1st of May, or basically May Day, or also almost universally the day where the world celebrating Labor Day, except some countries. We are also going to see the U.S. spacewalk, the EVA, extravehicular activities around the ISS, where they're going to install the IROSA panel, some instrumentations and what's on. And from what I know, it's basically almost 6 hours. It's around 6 hours and 35 minutes of doing that, doing that EVA. So it's going kinda, at least for me, it's going to be a bit endurance stream for me. Yeah, because also around that time, they are going to start for the spacewalk around, at least in my local time, at the 1st May would be 8 p.m. And basically it's almost 3 p.m. with it's almost around 2, maybe 2:30 plus, maybe almost 3 a.m. In my local time, where they finally finish it. And basically after that we can call it a day, and I'll be able to sleep properly. And hopefully I have enough sleep, because that's a very, very enduring stuff, I mean, I've already mentally ready for this, but man, I don't know how to say that. But that's it. I guess I'll be talking again soon, almost for around 4+ minutes from now. So that's it. Bye bye. See you guys later, and keep watching. Oh, on that note, if you're watching this, in Philippines, yeah, well, they are basically overhead of you, and it's pretty near to us in Borneo right now. Yeah, pretty near. And as far as I can say, it's it's an evening for us here. You know, you guys in the Philippines might already almost the nighttime right now, but here at least we are, at least from where I am right now. In Sarawak, it's 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 almost sunset. You know, so yeah, so that's that. So hello, it's passing almost near to us right now. Yeah. Oh, and also be good. We're going to see how they're going to ignite this stuff. And hello to the viewers. Welcome. Almost around 48 minutes and 16 seconds since liftoff. This is how the missions looks like. A little bit boring right now. We already have the first burn and then ballistic course threats right now, and we are almost going to see the second burn going to start, which will finally circularize the Biomass satellite to the 666 kilometers of altitude with the inclination of 98 degrees to the north. Basically kind of polar, but also sun-synchronous orbit, and also low Earth orbit at the same time. So that's that. And looks like it. I'll see you guys later. Gonna talk soon. And feel free to chat. Okay, and the commentary should have started by now. Let's see. Okay, so this is the replay of the liftoff. As you can see, this is the multiple camera views. Yeah, so interesting, right? I mean, at least more view and more photos for me to choose from next time for the Vega C launches. And to the new viewers, welcome and hello. This is how the liftoff looks like around 50 minutes ago of the launch of the Vega C rocket for the VV26 mission carrying the European Space Agency's or ESA's Biomass satellite. And now we are almost heading to the second burn of the oven blast. And this is how it looks like. Pretty nice view on the sunrise around the Amazon's rainforest area. So that's that.
In South America.
And here you see on the replay, this one is the second stage ignition of the Zephyro 40, and after that solid rocket motor taper off, and then ignition of the Zephyro 9, and then finally after that is the ignition of the Oven Plus, where it ignites hypergolic field using the RD-843 engines, not to be confused with the Russian. This one is the Ukrainian how do I say? Ukrainian upper stage rocket engine here. Yeah, I know. It's almost similar to the RD designation for the Russian, but not to be confused with that. Oh,
It's just
pretty interesting.
know
And
that
already
signal
signal
base station
acquisition,
yesterday, so
already
in
tracking
Vega C
acquisition
And we had
there
three
in
steps
the New
where
Norcia
the
in
first stage,
Australia.
so P120,
I mean, if you know, Australia is also one of the
then we
places
had the second stage,
frequently used by the
more than 2
space
minutes,
agency around the
so
world
if you
to
remember,
track
for
the
2 minutes and a half.
satellites and also
Then
rockets
the
around
first
the
boost
Earth.
of the Avon
If I
class
remember,
booster
also,
over Canada, and we had a launch
if I
boost
remember,
over
New Zealand also is one of the
without
places
propulsion,
also to
and then
track other than
we
this
had
one, and then
just had
Spain,
contact with the New Norcia ground
and
tracking
then
station, and we launched
finally, as you know,
via the Avon Plus.
it's US also at the same time.
You can see on the
And
left-hand side
we are
there
going to ready
what's
for the
coming up and what's
second
already
burn of the
been
Avon
and
Plus
what's
upper
coming
stage,
in white, and
where
I'll
it's going to
demonstrate on
ignite the
right-hand side of the screen.
RD843
We've got some
rocket
hot
engines
news from the Arianespace
that
Centre. The
burns
team's tested a
and
new
consumes
self-propellant
uh,
rocket motor called the
dinitrogen
P160. That was 2
tetroxide
days ago.
as the oxidizer and the
It's a
unsymmetrical methyl hydrazine as the fuel, which burn together without the help of igniter, because when these two combines together, it just ignites by itself. So ready for the ignition of the Avon Plus? Let's go.
This new motor is
Okay, and we looks like we have already ignition of the second burn of the Avon Plus upper stage with it.
And we've got here the switching on, that was the switching on of
Alright,
upper
and
stage,
Avon Plus has
which
already
now been
ignited.
confirmed. And here's the
And
picture. We can actually see
what
the
picture
hot
is
fire
it?
test
Let's see.
there of the P160 firing up.
And it's really key because it will increase the Ariane 6 and Vega performance,
Oh,
capacity, and
yeah, P160. This one is actually the upgrade for the P120. What it does is that, if I remember, it will add 1 meters of the height, basically an upgrade from the P120C 20. Let's just say, for example, if it's like how many meters long, it will add 1 meters in long in height, which will also add another tens of thousands of kilograms of propellants with some slightly more longer burn and a bit more higher thrust. So that's that. This one, the P160, will also be used not only for the Vega E upgrade, if I remember, but also going to use for the Ariane 6 Block 2 upgrade too. So maybe we'll see that debut at some point. So we'll see how. And in the meantime, this is the ignition of the second burn of the Avon Plus upper stage. We have ignition of the hypergolic rocket engine here, which in this case it's the Ukrainian RD843 rocket engines lead to the powering this up for the Avon Plus upper stage that burns and consumes the nitrogen tetroxide as the oxidizer and the unsymmetrical dimethyl hydrazine as the fuel, or we call this UDM hash. You know, it's pretty nasty, and that's the last thing you want to get very near it with. That's why if they have to fuel this this nasty propellant stuff, hypergolic, they have to use hazmat suit. And looks like we have already burnout of the we've already second burn end and ready for the biomass satellite separation. So let's go for that. Let's go. And looks like in terms of the orbit, looks like nominal from what I can see. Looks like pretty nominal there. Looking pretty beautiful. And now it's already moving. It's moving upward right now, going for the higher attack angle right now. And ready for the biomass separation. Let's go. Oh, right. Almost T plus 57 minutes. So ready for this one. We have 30 seconds before separation. So let's go for this one. Let's go. Let's go. So anticipating for this. So let's go. I'll shut up for now. You guys can see and focus for this separation here.
That's coming up in less than 30 seconds now. Very precise orientation maneuvers up there in space. These computer-generated images showing us exactly what's been planned for today's mission.
Fin de la manœuvre d'orientation.
So we have reached the end of the maneuver.
So we're getting ready now to separate biomass.
Séparation biomasse.
All right, and biomass satellite has already
Confirmation there.
properly confirmed it has already separated and going into orbit. And now
Great news.
the mission looks like pretty good. And congratulations to the Arianespace for the successful launch, and congratulations to European Space Agency. And now they have biomass satellite up into the orbit. Pretty good. Congratulations. So looks like at least for European Space Agencies, the mission is already started. And for the Arianespace, the mission is almost at the end. All that's left for them is the third burn, and then we enter back to the Earth's orbit.
CEO of
So that's that.
Arianespace, again, David Cavallolis, who spoke with us earlier. And look at
So you can see,
wonderful images
look at
there,
that.
computer-generated images,
This is
CGI
the animation, real-time animation of the satellite there.
Biomass. It looks like it's floating away, but it's actually traveling incredibly fast still, isn't it? It was 28,000 kilometers a
It's
second.
fast with respect to the ground, but it's slow with respect to the launcher. We want the separation to be gentle, not to have too high speeds to avoid any risk of collision. So it seems to be slow, but it's really fast with respect to the ground.
Teams here in the Mission Control Center, everyone very, very delighted now that we've had the separation. So let's go over now to David Cavallolis, who joins us once again from the fishbowl. David, thanks ever so much for coming to talk to us. So good news.
Yeah, absolutely, Katie. I'm absolutely delighted to announce that today the Vega C launcher, operated by Arianespace, has successfully placed into orbit its passenger, the Biomass satellite. I would like to very sincerely thank our client and partners, the European Space Agency. And today, with this launch, not only we reinforce the autonomous access to space for Europe, but also we contribute to make better life on Earth and to protect biodiversity. So this is really a huge achievement, and I would like to say a big congratulations to all the team involved, and thank you very much, and thank you to all our viewers all around the world.
Indeed, and it's a busy time here at the spaceport, isn't it, David? Lots of launches.
Les pressions sont correctes dans les réservoirs.
So, David, thank you very much indeed for coming to the floor and chatting with us. We wish you and the teams the very best of luck now for ongoing operations. David Cavallolis, thank you very much.
Thank you.
So, good news, Samuel, for good news there. We've separated our satellite, and
so sorry guys, a little bit busy, but it's fine.
To call home and talk to us, and this is going to take a little while because we have to wait for the satellite to come over the horizon,
Alright, so look at that.
spacecraft controllers
So this album plus upper stage will just only wait for the re-entry back to Earth with the third burn, you know.
Center, their mission control, where they fly the satellites. Waiting to hear from them later in the program. But first of all, I'm absolutely delighted. I've got somebody very special joining me here in the commentary box. She is the principal investigator, one of two principal investigators for the mission. Her name is
for now, I guess I'll leave them to explain to you guys about this mission before we end the stream. They end the stream, I also will do the same. So, and also hello viewers. We have finally separation of the Biomass satellite has already finally deployed into the Earth's orbit around the target orbit, especially the 666 kilometers per 666 kilometers of altitude. We are pretty funny devilish number at the inclination of 98 degrees to the north, you know. So it's polar. It's a polar orbit, but also at the same time the low Earth orbit and also sun-synchronous orbit, or also heliosynchronic orbit. if I remember correctly, hypersynchronous, something,
De l'étage
whatever.
Avon, les pressions seront nominaux.
But that's it.
Community
Just hear it,
make-
or what
take in
she said
charge
here.
the data and transform them to useful information and making use of it. Yeah.
Yeah, absolutely. And it's not the end at all. I mean, it's the end for some, but very much the beginning now of Biomass's life. Your new baby, it's in space, going through its early stages before it can start its job. That will be in about 6 months' time, won't it? The commissioning phase takes about 6 months before it's ready. Listen, I tell you what, I thought might be interesting to ask you, before we talk about the satellite itself. The satellite's called Biomass.
Yeah.
But what actually is biomass, the organic matter?
Normally, the name should be forest satellite, for example. Yeah, but biomass is because we focus on the carbon content of the forest. Biomass is a proxy of carbon content. About 50% of biomass is carbon. Yeah, and why it's so important? Because it's the dry mass of the organic matters in the wood, and plants, as you have seen before, the plants absorb carbon dioxide from the atmosphere and transform it through photosynthesis into convert into biomass. So the biomass is then a key information in the global carbon cycle, because the biomass density, which is the quantity of biomass per area, like we express it in tons per hectare or megagram per hectare. This density determines the amount of carbon emitted to the atmosphere by the forest when they are disturbed through burning, decay, degradation, etc. And then as the trees grow, they absorb atmospheric carbon, and then they increase the biomass. So we call we talk about the role of forest as a carbon sink to take over the.
Yes, and how much of a problem is this? I mean, as you say, we've often hear about the forests actually emitting carbon dioxide rather than absorbing it. How much of a problem is
Fin de la manœuvre d'orientation de l'étage Avon en vue de sa passivation.
I'm just letting everybody know that the range operations manager is still calling out
de la télémesure.
The various events, because of course the rocket itself is still going through its process.
Yes, okay. We know very little about what is the current status and the prediction for the future. Yeah, but measurement on the ground show that the forest in Africa can increase its carbon absorption, but decline elsewhere, like in Amazonia, like here. The forest seem to have a less and less capacity to absorb carbon. And so what happens if the carbon sink will not be there to absorb what we emit to the atmosphere? And so the CO2 will stay in the atmosphere, and with very big consequences on our climate. Yeah. So it's very important to know the present status of the forest and to predict with reasonable precision what is the future of that, the future of the carbon sinks.
Yeah, it is. It's hugely important. It's hugely important for all of us. I know. Yesterday, Thuy, you did something really lovely. You went into the forest because, of course, one of the forests that Thuy and your teams and all the scientists are studying is obviously the Amazon rainforest and the equatorial forests and the tropical forests around the Earth. And I think I'm right in saying that one of the very important research stations is actually here, only 45 minutes from the spaceport in the Amazon rainforest. What's it called?
Parakou.
Here, look,
station.
we can see you.
Yeah, okay, yeah.
What were you doing here?
Okay, so this is a long story. When we we want to design the mission, and we need to know about a lot of information about the forest and how we can do the measurement, or what kind of acquisition mode we can develop design, and also the algorithm to transform the data into biomass, height, etc. And then we need to understand a lot about the forest. So we went to the forest. The first forest I went to is in Parakou, here in French Guiana. And then I saw a very big plot, research plot. In total, they have 16 plots of 120 hectares. Of the biggest size is 500 by 500 meters. The smaller size is 250 to 250 meters. And they are doing measurement of each of the trees every year, every 2 years or 5 years. It's incredible work. And so this kind of data, we need to calibrate our methods and to validate our results.
So you're going to be using the information from the satellite to supplement and to fill fill the gaps, if you like, in data that you need.
The first thing is, until now, people used to do to have inventory on such kind of plot, but in the tropic they are very few. And how to extrapolate, you see, the result or the data from the research plot to the vast area of tropical forest. Or we need to have a lot of them, or we need a way like a satellite to extrapolate what we learn locally to regionally and globally. Yeah.
So just very briefly, before we leave you, because we're going to go to hopefully go over now to the European Space Operations Centre. Thuy, and you actually came up with the idea, didn't you, of the biomass satellite about 20 years ago? Just briefly, Thuy.
Yeah, it's more than that, because it was at the beginning an experiment opportunity when an aircraft equipped with radar fly over, and I have seen that.
And you had the idea, and I'm going to stop you because we are going to go hopefully now to the European Space Operations Centre. Thuy, thank you. Thank you so very much.
Thank you.
Everyone told her it wasn't going to happen, but it did. And
I
here we
can
are.
say hello to all my colleagues.
I'm going to stop you because we're going over now to the European Space Operations Centre and Thomas Ormiston. Over to you, Thomas.
Okay, thank you.
Thank you, Thuy.
Hello, thank you, Katie, and welcome back, everybody, to Mission Control here in Darmstadt.
All right, so this is the Operation Control Center right now. The Mission Control Center.
Our job is about to start here, but of course you can see on your screens there.
They are going to start the satellite, obviously.
That are getting ready to control biomass, to fly biomass. What's been happening over the last 10 minutes or so since you saw separation is that the spacecraft has gone down from Australia, where it separated, come under the South Pole of the Earth, and is coming back up towards the Atlantic now. And we have a station, a ground station. That's a big dish that we're going to use to receive the signal in Troll. That's in Antarctica. And it's currently sitting, pointing at the horizon, waiting for biomass to rise. And that's the point at which we will hopefully catch the signal from biomass. And of course, not just the signal, but that all important data of the spacecraft telling us how it's doing, that it's safe, that it's happy, that it's healthy. And that's exactly what we're looking for and waiting for now. The team is getting ready to see that data. What they'll be doing as soon as that data comes in is checking the health of the spacecraft. So, of course, they won't be jumping up and down and cheering. Don't worry if they don't do that, because our job here at ESOC starts at the very moment where we see that signal. So I think we're going to listen in now to the control room.
All right. So, hello, viewers. Now we are just waiting for the proper signal acquisition of the biomass satellite, which they will try to get that signal from the troll station located in Antarctica, of course. Okay, and what's that? Let's see. Let's go.
Acquisition de la télémesure Biomass.
All right, and the signal has already finally signal has already properly gained for the satellite. The Biomass satellite has already got that proper signal acquisition from the troll ground satellite dish located in Antarctica. We're seeing that. Yeah, so you can see.
And we're just waiting now for that confirmation from our flight director, Jose Morales, here at ESOC.
Oh, okay. I guess this is this is the Avum plus already re-entered back to Earth. I guess that's what they said. Oh, or they just like finally they be able to get something else. I don't know. So the Vega C's rocket job and the Arianespace job has already done right now. We're just waiting for the proper signal acquisition for the Biomass satellite. Let's see. This is from the Mission Control Center, located in Darmstadt, Germany. So let's see. Okay, and by then, if you see this signal has already properly acquired, you might see there's a little bit of the bump there.
We can't quite see the spike in that wobbly line, but that's not the only information that we have. Of course, our displays are lighting up green as well, which is good news that we are capturing data from Biomass.
Green.
The team
That's actually good.
Now, very hard at work. And we may listen just a little bit longer to see if we get a message from Jose Morales, the flight director, or possibly he's too excited by the telemetry that's coming in now. So let's listen.
Alright, so let's listen.
Longer.
If there's any, if the message sent finally receive an acknowledged by the satellite, we're going to see that. So the green signal is there. Just wait for the bumps spike up.
I think we're not going to hear from the flight director right now. I think we can forgive him that. Of course, this is a very exciting moment. Our screens there are lighting up with data from the Biomass spacecraft.
Okay, so let's see.
We have a new spacecraft and the
Let
teams
them
are now
speaking.
hard at work. There was some quick thumbs up before they had to get their heads down and start looking at the consoles, looking at that data. And right now they will be checking out Biomass and welcoming it to its new home in space. But here in the briefing room, this is our room next to the control room. I am very lucky to have Klaus Skipal, the mission manager for Biomass.
Yeah, this is a little bit like interview stuff while they're waiting for the Biomass satellite. More like it's no longer about signal acquisition, it's more like the acknowledgement. So we are waiting for that. And yes, I have already streamed almost 2 hours, you know. Wow, what a time passes. And after this, I'll have my dinner, you know. So, and maybe I can rest a little bit more, so I can be prepared for the Firefly Alpha rockets that will lift off for the FLTA 006 mission that will carry the LM400 tech demo satellites for the Lockheed Martin. Yeah, so that satellite would serve mostly for the defense industry, but maybe commercial will have some value. We'll see.
For Biomass, it's a bit special. It will take a bit longer.
Okay.
This has to do
And
with the special shape of the satellite.
meanwhile, hello again.
With this big umbrella that sits still on the back of the satellite.
Some emoji doesn't hurt, you know. Let's do that.
Several steps, so it has 3 arms that unfold with time. It starts to wobble at each step, so we have to wait until it stabilizes again, and then we can plume the satellite so we can unfold.
What we are waiting right now is just the signal spike, basically just the acknowledgement from the from how do I say, from the satellite, basically acknowledge that yes, I'm alive, like just that kind of stuff. So just wait.
All the scientists, I think everyone is waiting for this since 20 years now.
Wow, no, it's going to be really fantastic. And I mean, yeah, as the mission manager, what are your personal expectations for the success of this mission?
Of course, with the mission, our big goal is to determine how much carbon is stored in the forest globally. This will be what we are measured against at the end. But for me, Having the first time in space a P-band SAR, I think every step we take now is already a big success. So having the signal now was already a big success and real relief. Getting the first image will be the next success, and then taking routine observations. I think this will be with every image we will get in. It will be a success. People will discover new things.
Yeah, little stretching, you know.
Fantastic, yeah. And I mean, the people that will get excited, I mean, who will be the main users of biomass data? I mean, I assume primarily scientists, but could the data have an even further reach to policymakers or beyond?
Of course, it's an Earth Explorer. It's the first time we have a P-band in space, so there's a lot of scientists involved, and at the beginning our main community will be the scientific community, and that's the main purpose of the mission. But because forests are so important in the global carbon cycle, there's a whole market currently building up around this. We give incentives to countries to protect their forests, for example. And of course, people want to control this, and there's companies who are offering these services. And of course, they're very interested in this mission. It will take some time. I don't think we will do this from the first day of the mission, so we will take some years. But we're already talking to these people and preparing them for this mission. I'm pretty sure at the end of the mission, they will use this data.
Exciting, yeah, no, it's really exciting what the reach of this data is going to be. But of course, I mean, we didn't just arrive here today. This mission has been a long time in preparation. It's a big project, and it must have been a challenge just to get here. Can you tell us something about how the teams, of course, have overcome that and got to where we are today?
So as every satellite we build, especially Earth Explorers, because they are so new, we build new technologies. It's a long journey. So we started, I think the first proposal we get 20 years ago, 2005, and you saw some of the scientists behind this mission just on the screen. Some of them even retired by now. So to keep this team up and to go 20 years is, of course, a challenge in itself. But I think everyone was so excited about this mission, so it was not a big issue. On the way, of course, you face a lot of engineering challenges. We build a lot of the things we have on board were first of its kind technologies that had to be built. The reflector we have here, I think we never had a reflector this size in Europe. I think it's the first reflector ever that we do in Europe. It's the first P-band SAR, which is, of course, posing a lot of issues, starting with the requirements at the beginning. You have to build something which you do not really know. You have to start to explore with little data sets that you collect here and there. So these are all challenges you face. These are typical engineering challenges, which I think at the agency and at the industry we are well prepared to take. We are equipped for doing this job. But then on top of that, there come other challenges. We have developed this satellite at the height of the COVID crisis. If you take, we were 50 companies involved, spread over 20 countries, 700 people at the peak of the development time, and then you are in lockdown. You cannot communicate, you cannot test as you planned. But everything, I think, at the end went very smoothly, and we got there, and now everyone is excited.
Yeah,
all problems are forgotten.
Oh yes. Hopefully we won't find too many new ones, but of course the control team here is ready for the challenges. And I mean, that's the next question from me is, I mean, the challenges don't stop at launch. I mean, challenges or excitements maybe don't stop at launch. I mean, what sort of things do you expect to be challenging, difficult, interesting during the operations phase of the mission? I guess there's some special tricks you're going to need to do to acquire this data, to process this data, to make it usable.
So one of the big challenges of this satellite is, of course, to acquire global images. It was mentioned previously that we have to change our orbits all the time. So there's a mission that is permanently in move.
Looks like from what I can see,
a lot of challenges for the operation teams.
Looks like this first signal on the left side, it has already raised this at around same level of the second signal. Interesting. Just only waiting for the bump. You know, once the bump happens, yeah, that we know that like it's pretty healthy, and they finally acknowledge this signal, you know, that was sent by the mission control operation here in Darmstadt, Germany, via the Troll ground station located in the Antarctica. That's that. Yeah, I'm still waiting, and I do not want to talk right now. And I just want to let them talk right now. So that's that. Shut up for now. We'll do some occasional door knocking once in a while. So that's it.
it was only snapshots, and now we get real data in. And we will learn with every image that comes in. We will learn. We know a lot, but I think there's also a lot of unknowns that we face and that we will need to deal with as they come.
Absolutely. No, thank you ever so much. Yeah, the unknowns they can be exciting, they can be terrifying. We mentioned it earlier that, of course, unknowns here in the control room tend to spook us a little bit, but the team behind me are very well practiced, and I promise you, Klaus, that we will take very good care of your baby for its whole life, flying it here from ESOC. But right now, I think we can hear from some more people in Kourou, so we'll let the teams work. Stay in touch on ESA's channels to find out more about what the Biomass mission is doing. But for now, back over to you, Katie, in Kourou.
Thank you very much indeed, Thomas and Klaus. Great to hear all of that, and great congratulations now as you take on your new baby. So let's hear now from
so
the
that's ground control in UK, huh? Which one is real? Which one is true? Jumpstart Germany? Huh? UK? Okay, I'm a little bit confused here.
Space Agency. Tony Tolka-Nielsen, who is the Director of Space
Okay,
Transportation.
another
ESA.
interview.
Ranzo, who is the Chief Executive Officer of Avio.
So,
And we have Mark
yeah, I'm
Stanton,
still
who is the
thinking
Head
here.
of Earth Observation, Science and Exploration at Airbus, who are the manufacturers of the
You know,
satellite.
that kind of
Simonetta, let's start with you.
suffering.
You and your colleagues at the
Terrible,
European Space
the
Agency
pain
and in Earth
kind of
Observation must be
memory.
absolutely
So,
delighted now that you've got this satellite in space.
Thank you, Kathy. We are extremely thrilled, delighted, emotional of this fantastic, successful launch. Biomass is a great mission. We heard all about it. It's a mission which serves citizens, health, science, innovation. It's an Earth Explorer. It's part of FutureEO. 20 member states of ESA have contributed to that. So really thank you for the support we got from member states. We worked with Canada and the US on this mission. And about 50 companies all over Europe, 700 engineers worked on the development, and Airbus UK with Airbus Germany building the instrument. This new radar, P-band radar, which is really a fantastic instrument to look at tropical forest, 3D vision of the carbon fluxes on all what we need to know. But now we're going to go to also thank you to the teams. In fact, the project teams did a fabulous job.
This part might be boring to you, feel free to actually feel free to just go back and watch the launches and what's on, you know, the most exciting thrilling part of the stream, you know. Or you can just wait for the stream to end and rewatch my stream again. That also can help. So that's that.
Overall, and this mission is really at the core of that. Just yesterday in French Guiana, we have 2 calibration validation sites of that mission, and a lot of work will be done through 100 validation sites all over the world for a project called GeoTrees. So big thank you to all these collaborations, and this is quite unique in Europe. I must say thank you also to Arianespace, of course, to Avio, for delivering the satellite into the right orbit, which is essential. Thanks a lot.
Indeed. And let's go now to Tony Tolka-Nielsen. Tony, the Director of Space Transportation at the European Space Agency. Tony, it's a very important day, isn't it, for European access to space?
Sorry, yes, absolutely, Kathy. And it's a great day to be a Director of Space Transportation, especially in this moment. The mission I happen to know very well because of my history, and I knew how important this mission was. And it's, of course, very, very special to have an ESA satellite, very important one, a scientific Earth Explorer, and an ESA launcher operated by an ESA Space Satellite Operations Center in ESOC. So a very special day for ESA. And this was the first flight of Vega C after the return to flight. And Vega is back and really consolidated. We have also done 2 flights with Ariane 6, and we will say we are back with space transportation and access to space, and this is great, and exactly this mission indicates and demonstrates how important Europe's access to space is, and we have now restored this and we are ready and ramping up both Vega C and Ariane 6. So, but for now, really great with this biomass mission, which is a great mission. And I wish all the best for this satellite. Thank you.
And Giulio Ranzo, you're the Chief Executive Officer of Avio. Avio, the company, of course, who built the rocket, the Vega C rocket. She performed flawlessly today, didn't she?
It seems so. So the Vega C launcher performed accurately as it has done also over the last flight for Sentinel-1C. It seems a very accurate orbital injection, which is a very important feature for a rocket. And it has consolidated very well, as Tony was saying, the capability of Vega C to launch to space the most important Earth observation missions for Europe, not only for the European Commission, but also for the European Space Agency and for other European agencies. So I wish we will have so many other missions for Earth observation. This is so important for our planet to observe what we do, but this could not be done without a rocket that delivers accurately the satellites to space. And for this reason, I'd like to pay a particular tribute to my team at Avio for a very, very good job at integrating this rocket. Imagine this is a machine made of 30,000 parts, all of which need to work flawlessly throughout the flight and receive very relevant shocks. They have done a phenomenal job, and I could not be more proud. And I ask you to pay one big applause to these people who are sitting here. Thank you.
To be honest, if you see behind him, it's actually a pretty interesting telemetry there.
For building such a
so which means not too far away before they finally before the Avon Plus upper stage finally went back to Earth, you know, atmosphere. So we'll see.
But I would like to underline as well that that success would not have been possible without our teams, without their engagement, dedication, and hard work. And as you know, it took us 9 years to deliver that satellite, and now it is in orbit. A big thank you to ESA. A big thank you certainly to Avio and to Arianespace in order to put that satellite successfully in orbit. The interesting part is now going to start. We are starting the commissioning phase, and then the official handover is by end of the year. So the only remaining word I would like to say to Biomass.
So basically almost 6 months, right? Okay, interesting. I mean, interesting. We'll see.
What a fantastic collaboration of teamwork. Well, we're at the end of our program now. It's mission accomplished so far. Congratulations to everybody and all the teams at the European Space Operations
Looks like we don't see any signal bomb, but whatever.
Congratulations to
Still
everyone.
good.
For
We are at
people
the end of the stream. So let's see.
Story, and for others, it's the beginning of a new chapter, as we mentioned. So yeah, good luck for the next steps, and go Biomass. Yeah.
Yeah, absolutely. Stay tuned for the press conference. That's in about half an hour, and that takes place at 8:15 here in Kourou. That's 12:15 Universal Time and 1:15 in Europe. But for now, from Samuel Rogers.
And from Katie as well.
Bye-bye.
Goodbye.
Okay, so that's it. Good day, everyone. And look, and look this. Okay, this is the replay. I mean, I'm not going to host that press conference because stream the press conference because it's not too exciting. I mean, you can go yourself and watch from the Arianespace YouTube channel here if you're interested. And this is how the liftoffs looks like. Pretty interesting, isn't it? So yeah. Okay, you can see back when almost 2 hours ago when it launches the rocket and also the satellite. Looks pretty interesting there. So yeah, that's the story. And this one is this separation of the first stage of the P120 and the ignition of the Zephyr 40 on the second stage. So that's that. So this is it. I guess I'll let the credits roll in before we finally finish it, because yeah, some acknowledgement is still better. Oh, and what's up with that? It's going too fast. What's it? That's funny. Oh, and thank you. Love emoji. Love emoji, love emoji, love emoji, love emoji, love emoji. Okay. Okay, I'm just kidding about that part. Okay, so let me chime in. So that's it. The launch has already finished. And yeah, I guess I'll see you guys later if the launch did not cancel for the Firefly Alpha rockets. Hopefully not going to get scrapped anytime again. Because that's another opportunity. Will be almost three, like already less than 3 hours from now. So we are going to see that. Okay, so that's that. Already finished. It's just repeating itself over and over. So that's it. We are going to see that soon. So bye everybody and take care. So yeah, something else you want to see on the behind the scene or behind the screen? There is nothing here. I've already finished my thought. Yeah. Peace. Bye bye. So let me go here, do some code. Yeah, so see you around for the next launch of the Firefly Alpha FLTA 006 mission that will carry the LM400 tech demo satellites for the Lockheed Martin. And the launch provider will obviously going to be Firefly Aerospace. So that's that. Goodbye everybody, and let me do this. Oops, I've already closed my. Okay. And this is how it looks like right now. So yeah, I don't have my avatar, but whatever. I'm going to use my tech line here. So this is Daniel Suguwa signing out, and goodbye. Take care everybody. See you on the next stream. Not going that long, maybe around less than 3 hours from now. So that's it. Bye bye. Take care.